Good morning and welcome to the LMI webinar series. My name is Aaron, I'm Training Program Manager, and today we have with us Nathan Funk, Technical Product Manager, as well as Robert Uebbing, our Technical Product Manager as well. They are our subject matter experts. They're the gentlemen who put these products together, and they will be speaking directly about it. So this is really your chance to ask any questions you may have. Today, they'll be discussing the Gocator 6.1 software beta, the new software release, and this is basically just going to be a preview of new features and enhancements, plus a demonstration. So before I hand it off to them, I do ask that if you have any questions during this presentation, please ask. We are happy to answer them. We will do our best to get answer all of them, really. But please use the chat in the right-hand side of your screen. I'm assuming my video is not flipped. So there's a chat on the right-hand side of your screen. Just pop those in there, and we will address as many questions as we can, hopefully all of them. One other thing also to do with the chat, if you have recommendations or requests as to future webinars and topics that you would like to hear us address, please add those in as well. We're happy to talk about any of that. And the one final note is we are recording this, so you will be able to watch this again at your leisure. Please keep an eye out in your email box. This should be available in a couple hours from now. So without further ado, Nathan, I will hand it over to you.
Thanks a lot, Aaron. This is really about a bunch of new features. Again, new release, lots of new features coming in. So I'm going to take you on a whirlwind tour through all these new features coming in. Feel free to ask us questions in the chat, like Aaron was saying. And we'll take breaks in between to try to answer as much as we can. So we'll try to keep it interactive that way. So just as an overview, I'll be covering 360-degree inspection. So specifically introducing mesh alignment and stitching tools. Then the wide layout alignment improvements, new tools such as surface template matching and other ones, GoHMI SDK, and G2 translucent material. So there are many other features as usual that we're also packing into the release that I won't be covering, but you'll see those in the release notes with the beta release coming up. So first of all, talking about 360-degree inspection, you can imagine that with a ring layout right now, you can get data from around a part just with a ring layout. We've supported this for quite some time already. With a set of Gocator sensors, so you can buddy up 4 sensors like illustrated here, and get data from all these sensors. But there are some limitations that I'm going to talk about around this, where we're making improvements. So imagine that you're using a system like this and trying to inspect a part like this on the right-hand side, and you've got a bunch of measurements and tolerances that you want to check against. On this part. So you can imagine that in some cases, it's not just about the measurements that you can see from one side. It's also about the relationships between the measurements or between the locations from side view and the top view, for example. So you're checking for perpendicularity, parallelity, and you have to do more than just look at it from one direction. You actually have to be able to relate things, and that's where things get hard, because now you need to actually combine this all into one. And if you had separate scans, if you had somehow broken up your system into separate stages and you scanned once from the side and once from the top, then you don't have that benefit of having everything in the same coordinate system. So really, this is all about bringing everything together into one scan so that you can perform all your inspections on this one scan that you have with a 360-degree view of your part. So just talking about the current challenges that you have with 6.0 and earlier software, you can perform a lot of measurements if you turn uniform spacing on, but turning uniform spacing on causes loss of the vertical data, and overhang areas also do not get covered. So you'll see if you have a round part like this, thinning out of points in these areas, or complete loss of data in vertical regions and in overhang regions. And of course, this causes measurement challenges just because you have fewer points, so your accuracy is diminished. and just placing measurement tools in these areas becomes difficult as well, because it's hard to get the side view where you would want to actually operate from the side. So the challenge with turning uniform spacing off is that you're getting a point cloud, and that point cloud is actually unstructured. There's no specific order to the points when you're merging the data from multiple sensors together, because they just get added. The points just get like concatenated together in arrays, but there's no clear order in 3D space really with those points. So that's difficult for us to operate on efficiently. And for that reason, we currently only offer profile measurement tools for ring layout, and we don't have any raw surface mode measurements that would allow you to operate on this point cloud data. So we are introducing a new data type. This new data type answers these challenges. It contains not just the points that you've scanned, but also triangles that relate those points together. So the huge benefit here is that now the data has been organized. We've created some structure from that unordered point cloud, and now running algorithms to analyze that data, perform measurements, is a lot more efficient, and we can now actually do things in a lot quicker times, and give you the measurement results that you expect from all angles, because now we've built up that mesh. So in practice, what you're going to see in the firmware are at least 2 new measurement tools for doing the bare minimum of just generating a mesh. First of all, we're adding a new tool for alignment. So previously, alignment always happened in the scan page. This is actually a tool that performs alignment. So the tool will run in the measure page. You will be feeding in the raw surfaces. So this is just uniform spacing unchecked. You're feeding that into this tool, and it will be creating a alignment XML file. That alignment XML file stores all the alignment information, and that is read by the surface mesh tool to perform the transformation. So the neat thing here about the alignment is that this is in full 6 degrees of freedom. So it's super accurate alignment through a special alignment target that I'll be showing on the next slide. And with that alignment, you now have a way of getting very, very high precision alignment in your surface data, and thus the ability to generate a mesh very accurately. So the alignment is something that you only perform once, and then the transformation through the surface mesh tool is something that you would be performing on every frame for everything that you scan, and it reads from the XML file to get those transformation parameters. So talking about the alignment target, this is the new double-sided pyramid target that we're introducing as part of this release. The CAD will be available, and you can scale this as you wish. You just have to enter the dimensions that you have of your target in the tool, in the alignment tool. So it needs to know exactly how large it is, but you can scale this to, depending on the size of your setup. And the important thing about this target is just that it allows us to perform very exact fits of these plane surfaces, and thus get very accurate alignment of the sensor positions. So moving on to the other tools that you can use the mesh data on. First of all, we're introducing a mesh template matching tool. This performs 60 degree of freedom matching and outputs the orientation, deviation statistics, and the transform mesh. Then there's also mesh projection that allows you to get from mesh to surface. Mesh plane, going from a mesh and extracting a plane geometric feature. And mesh bounding box to get location and dimensions of a specific area of your mesh. And I'll just talk about these first 2 in a little bit more detail, because they're the most interesting, and then I'll demo all of these in screen share in a bit. So first, mesh template matching, like I was saying, does matching in full 6 degrees of freedom. So this is comparing your current scan against previously acquired data, and then fitting it so that you can get a exact orientation. So it will give you the offset and rotation of that part so that it matches the orientation of your golden part. It also calculates deviation statistics and outputs the aligned mesh data. So you can see that output mesh data after it has been aligned and operate on that for your measurements. Then the mesh projection tool. This is a really important tool because it allows you to get from a mesh into a surface height map. And this is important because once you have it as a surface height map, you can use all the existing surface mode tools to operate on your mesh data. So you can picture this as just generating a view of your part from any specific angle. So you could be looking at from the top down or from the side. You're basically generating a height map from a specific direction. And so this allows you to perform measurement in these difficult areas like the sides or the overhang areas because you can generate a view from that specific area such that you're perpendicular to that surface and get more accurate measurements that way. So yeah, I'll just start my screen share here. I've got an emulator scenario loaded. Just give me a second. Here we go. Okay, so this scenario is loaded with a scan target here. So I'm looking at this from a ring layout with 4 sensors. And you can see this is the input into the alignment tool. So it's just a random bunch of raw surfaces that have not been aligned. So if I go into the scan page and look at the alignment, you can see here it's unaligned. And if I look at the transformation, everything is 0. So this is just showing that the alignment is not using the scan page alignment at this point. It's just using the mesh system alignment tool. Sorry, this name is changing. This is going to be the surface align ring tool. So sorry about the name confusion there. That will be renamed soon. So the tool is taking in these surfaces that have not been aligned yet, and it also has the configuration of the double-sided pyramid. So we have these parameters entered here. That's what I was talking about earlier. And then the final output of this is a XML file. And the contents of the XML file are best illustrated here in the input into the mesh stitching tool. So this is basically using the XML output from the alignment tool after you've performed the alignment. It basically has the exact sensor position. So here we can see the field of view of our sensors that have been calibrated using the alignment tool. And you can see from the top down, it's even finding that the sensors aren't perfectly aligned so that the laser plays are coinciding. That doesn't matter anymore. So you do not need to put a lot of effort into mounting your sensors very accurately because we can compensate for any sort of angle that they are mounted in. So as long as they're rigidly mounted, we will find very accurately the exact offsets and angles, and the laser planes do not need to coincide with each other. So the tool here that I'm showing brings all the raw data together by performing this transformation based on the alignment results. And the output of this is the actual mesh. So now I have a final 360-degree scan of this part, and it's fully matched from all the different angles and brought all that data into this one coordinate system. So this is now something I can operate on with the mesh tools and also use the mesh projection tool to bring it back into a surface mode. So just quickly going through the different mesh tools, we've got the mesh plane tool. You can imagine what this does. It's just looking at a little region on the side here and fitting a plane to it. This has a bunch of handy modes here for the plane detection mode, for example. We can also do by largest area, maximum distance, minimum distance. And so these different modes allow you to very robustly perform fits beyond just including all the points in the region. And that will give you additional accuracy in cases where you may not be able to place the measurement region very accurately. Moving on to the bounding box tool. I've just got that illustrated here on this little tip. This is just the mounting of the target. But you can see here how it is fitting a rotated bounding box. So it's not just an aligned bounding box, but actually a rotated bounding box that we're fitting there. And it will give you the offset and the orientation of that bounding box. So of course, this is very useful for just determining the location of a part within a region and getting its orientation as well. Then moving on to mesh projection. This is the tool that I was talking about, giving you a view from any particular angle. In this specific case here, I've got it set up to use the output from the mesh plane tool as the input into this mesh projection. So that means that my XY plane is now going to be matching exactly with the plane fit on the side wall of this part. So if I look at the output here, what we'll see, I'll just look at it in 2D, is this height map that's generated from that side view. So here you can see that we've got this perfect alignment of the side plane. So that's perfectly flush with the XY plane. And then the surfaces that are tilting away from that main plane. And the great thing here is that now that I have this surface data as a height map, I can actually use any of the existing surface tools. And you can see how I can scroll through all the ones that we've built up here over time. We can use all of these tools on this side view. So really, you can do all the measurements that you're used to within Gocator on the side data. And finally, mesh template matching. This is just to show you the different parameters here. We've got the basic operations, so I can create a template here, match against the template. It also performs a it's an iterative approach, so I can set the maximum number of iterations to limit the time that it takes. I can perform a deviation statistics, or I can collect deviation statistics, so I can actually see a bit of a histogram of the deviation, and also output the mesh as a file, so that I can view that later and look at the deviation in a separate tool. So this is a really powerful tool, and you'll be able to try this out for yourself in the beta release. Okay, I'm going to switch back to the webinar here. Going back to the slide.
And
yeah,
actually, I was hoping we could I could pause for a quick couple of questions. Sure. I see them building up here.
Yeah, great.
Yeah, absolutely. I'm going to try and consolidate all these questions and all into one. So previously, when you're doing the demonstration, you mentioned old data versus new data. Could you clarify what you mean by old data? And does that old data, is that stored in the PC or the sensor? Do you have to move that around?
So the old data is stored like for mesh template matching. I assume that's what we're talking about. That is stored in the PC. So yes, that is the template that you're comparing against. And something I was going to point out on these tools is that we do expect that you're using PC for most of this. As you can imagine, operating on the mesh is quite CPU intensive. So you will be using a PC at least for the alignment part, and then probably for the other operations as well, just because they are quite intensive. So yeah, that gets stored on your PC as a file, and you can use that to perform the comparison to subsequent parts.
Excellent. Pawan, I hope that answered your question. And then Pawan's also asking, is GoMax recommended for this tool, or can the sensor handle? I think you've already addressed this, though.
Yeah, it's really PC acceleration that we recommend for all of this, because it is quite intensive. So you will use a PC to perform the alignment. It generates a file on your PC with the alignment details, and still, like for the other processing, like I was saying, it's all PC acceleration that we recommend.
Excellent. And then one question from David for template matching: could that be used to find defects?
Template matching, yes, it could be used to find defects as well. Yeah, if they're like a high enough deformation from the template, then you could also find defects that way.
Excellent. Thank you.
Okay, then moving on to wide layouts. So we are making a change to the way you can align, or adding functionality basically to the way you can align wide layout systems. So previously with wide layout systems, if you wanted the most accurate alignment, you would use the moving bar alignment, but that's still missing the X angle. So in this illustration here, you can see it colored in gray, the little arrow in gray around the X-axis. That is the angle that we were not able to calibrate for previously. I mentioned that for the ring layout, we are adding that capability, and now we're also adding this capability to align for that angle with the wide layout. So without this, you'll see some inaccuracies or seams, like specifically when you're looking at micron level comparisons. Usually this X angle doesn't cause too much of an issue, but it will cause issues if you're looking at the micron level and trying to align multiple sensors very, very accurately with each other. Then you can see even the issues with an X angle, and obviously, like I was saying earlier, the difficulty here is that to avoid seeing issues with an X angle that you have not aligned for, you have to ensure that your physical alignment of the sensors is as accurate as possible. So you'd be trying to make sure that the laser planes coincide with each other as best as possible, which is obviously a lot of effort. Secondly, the transformation, if you do have a X or Z angle in your transformation, then the additional processing is significant as well. So we perform a slightly different angle, we perform a slightly different transformation process. The algorithm is different when you have an X or Z angle, just because it involves basically sampling over multiple profiles to generate one profile that's aligned with the XZ plane. So with that, you will see higher speeds, and that's been another limitation that we've had so far. So these are things that I'm talking about for 6.0 and earlier have been limitations. So what we're introducing for wide layout is a new alignment target and a new alignment tool that allows you to very accurately get even the 6th degree of freedom and get an X angle. So the look of this alignment target is very similar to the double-sided pyramid that I talked about for ring layout. It's a set of truncated pyramids from the top, and you would just have as many rows of these, or sorry, as many columns of these as you have sensors for. So in this case, this would be for a 3-sensor side-by-side system, where you would have one sensor scanning each column of these pyramids. And again, just due to the physical characteristics of this, we can get very accurate alignment by performing plane fits on these areas. So just to give you a sense of these tools, again, there's 2 new tools similarly named. Surface Align Wide is the new alignment tool. It operates in the same way as the Surface Align Ring tool. So you would get a raw surface, so you have uniform spacing disabled, all of your transform values set to 0, and it will perform the alignment on this raw input of the calibration target and produce an XML file. And of course, again, this is all 6 degrees of freedom and stored for you in your PC. Then you load that XML file to configure the surface merge wide tool, and this performs the transformation for you. And the benefit of this tool over the transformation that you would have typically on the scan page is that this is running a lot faster because it's taking in an entire surface rather than operating on a profile by profile basis. So you can perform this transformation in full 6 degrees of freedom a lot faster than you would have been able to if you had entered those same angles on the scan page, just because it's operating on a surface by surface basis. So just looking at the actual outcome of this, if you had poor alignment previously where you had a significant X angle, your results would look something like this on the left. And if you use the new alignment method to align your sensors more accurately, we basically can even out that plane to the point where you just don't see any seams at all anymore. And again, just a reminder that this is for PC acceleration. So the alignment target, the alignment process itself with the alignment tool will create that XML file for you on your PC, and you'll use that to perform the setup of the transformation tool. And once it is configured, just to be clear about this surface merge wide can technically also run on sensor. You just have to perform that initial configuration on a PC. And as usual, because this is quite intense, performing the 60 degree of freedom, depending on the speeds that you actually want to run at, you'll have to decide whether you want to have this accelerated or not. Okay. Any other questions that have come up, Aaron, before we move on to the next one? Doesn't look like anything. So I'll just move on. Doesn't look like there's anything new. Okay, so moving on to surface template matching. We've got the current limitations of part matching and anchoring. These are the two main approaches that you would use currently for dealing with random part orientation. So this is the problem where you have a part that is located randomly on your conveyor, for example. It might also be rotated randomly, and you want to perform measurements on these parts in a consistent manner without having to reposition measurement regions with every scan. You can do this currently through part matching or with anchoring, but they do have some limitations. So part matching itself on the model page is not suitable for partial parts. So it only is designed to work with a scan of a full part, like you can see in the screenshot of this hinge. If you have that, you're good to go. It will, in the edge mode, generate a model. You can generate a model and then perform the matching based on that. But there are other limitations around this as well. So if you do have a whole part, you still can't find multiple instances of that model. You can only find one. It's expecting that you've run through part detection first and separated your parts, and then you're matching against those separated parts. So it's only ever looking for a single instance. And it only matches against a single model. So if you had different types of parts that you wanted to match against, you would also be stuck with this because this is only using a single model at a time. You can create multiple models, but you can only select one that you're comparing against at any point in time. And then finally, there's no flexible pre-processing. So there's not much you can do to prepare the data before it comes into the part matching tool. You're limited to the filtering on the scan page at the bottom. That's all you have for performing filtering in advance. And then for anchoring, if you've tried this before, you know that it can be difficult to set up. It can also be fragile if you don't have your regions positioned accurately. Then anchoring can be fragile. So while anchoring has its place for specific applications where you know that maybe the rotation isn't very the rotation doesn't vary over 360 degrees, for example. It's just a few degrees rotation. Anchoring might be appropriate because it's fast, but in these general use cases, it can be difficult to set up and it can be fragile to use. So we're introducing a new tool called surface template matching, and this tool is performing contour-based 3D degrees of freedom matching. So it is actually generating a template similar to the model page part matching, and performing X and Y offset and Z rotation to match that model to your current scan. The main benefits of it, though, are that it can now locate multiple instances. So you can find multiple instances of a part. I've got some screenshots showing you that. You can match multiple models. So you can have multiple instances of this surface template matching tool. You can just add another surface template matching tool with a different model to match against a different model. And you can also match against variable scales. So if your parts are varying in size, that can also be dealt with and actually measured. And just because it is a tool, you can perform pre-processing, for example, using all the different filters in the surface filter tool. You can perform any of that or any other tool that manipulates your surface before bringing it into surface template matching. All of that can be done just because surface template matching is a tool rather than built-in functionality. So with this tool now, we have mesh, surface, and profile all covered with template matching tools. So all of these data types now in the Gocator framework with 6.1 will be covered with template matching. So just some illustrations here to show you what the results look like from the template matching tool. This is an example where I have generated a model just based on a small component on this PCB, and it's finding 3 instances of it just based on the size. So the outer dimensions of the part are being used, and it effectively locates these parts very quickly. Then we can also get the show this example of capacitors similarly on a PCB, locating them very accurately and quickly here, giving you multiple, the location of multiple instances of those. Then illustrating the variable scale, this is scans of bread. You can imagine that these loaves might vary in size. So with the variable scale feature, you can actually match to the part. If the shape is still similar enough, it will match independently of the scale and perform and also give you the measurement of the scale, so you can get both the location, orientation, and the scale of your part from this tool. And finally, just to illustrate the difference with partial occlusion. So if your part was not fully in the field of view, like you can see in this illustration here, or in this shot, you'll see that I'm using this as the template and performing matching against that. And as the part moves around, you can see that it's matching the model edges or the contours very accurately against the moving parts. So as I step through here, you can see that on the right-hand side, while the frame of the image is changing, the part location is not changing at all. And this is just due to the accuracy that we can get with this vector-based comparison of the contours. We're actually at the subpixel level in getting the orientation of rotation of the parts. And so this is a very highly accurate way of just getting a very steady position on your part. And the best part of this is that it's really dead simple to set up. Like, I literally, for this example, just created a template from the entire field of view. I didn't manipulate it at all, and then ran it on these other scans, and it gave me these results with no effort at all. So it was really just a matter of a few clicks setting that up and getting those results. Finally, if you do need to edit your model, so if you've got noise in it or whatever you need to clean up, we do also offer a model editor that will be provided as part of the utilities package. And with this, you can make any changes to the model if necessary. Then moving on to other tools, we've got a set of different tools that are also being added. On the profile side, we're adding profile filter, profile mask, and profile transform. So of course, these sound similar because we already have the surface mode equivalent of all these tools. These basically do the same thing. So profile filter will be very handy for additional filtering. If the filtering on the scan page isn't sufficient for you, you'll find more options in this new profile filter tool. Profile mask allows you to mask out multiple regions, similar to the surface mask tool. And finally, profile transform allows you to perform any sort of rotation or offset on your profile. And then in surface mode, we're adding the surface cylinder tool that performs a cylinder fit. So this is slightly different from the stud tool that we've had previously, where you would measure the orientation of a stud coming out of a surface and specifically be looking for things like the angle from the surface, is it perpendicular or not. So this cylinder tool is a lot more generic and lets you operate on anything that's cylindrical, find the center axis orientation of that, and give you radius as well. So it's a very powerful tool for anything cylindrical. You can imagine there's a million cylindrical things that you could operate this on. And then finally, the surface rotational distortion tool removes distortion from rotational mounting. So you can imagine that you would have your part perhaps on a rotary table, or your sensor on a rotary table, or on an arm that's swinging over your parts. So if you have these cases, you'll probably seen that creates a distorted scan. And this tool allows you to remove that distortion by compensating for that rotation in your scans and give you the actual part geometry. Okay, then moving on to a new piece of functionality also included in the utilities package is the GoHMI SDK. So this is a SDK for creating an HMI application. You do need some programming to be able to build this HMI. So this is using Visual Studio. You would load our SDK. There's sample applications included, and basically make modifications to the sample applications, or you can also build anything from scratch. But the big benefit here compared to building an application based on our regular Gocator SDK from scratch is that this GoHMI SDK also includes the 2D and 3D visualization components for you. So the plumbing that's necessary to feed the data into a visualizer and the visualizer itself is all taken care of by this SDK. So as you can see in this screenshot, we've got a 3D visualizer inside this Windows application. And through the examples, you can see exactly how this is done and do this for yourself in whatever custom manner you need. But that's really where this is helping out, is if you needed this for any application and you wanted to build it up, you would have to go through a lot of effort. We've done all that hard work for you and taken away that effort of building up the visualizers for both 3D and 2D. So it's a lot easier with this SDK to create an application such as this one. This one's just really simple, showing start and stop, but even just showing jobs, the measurement values, all of that is illustrated in the sample applications. It makes it a lot easier for you to get started building a Windows application that allows you to perform or to show a simpler user interface than the Gocator web interface, and fully customize that. And then finally, the last feature I wanted to cover is the translucent material support. So this is specifically useful for applications where you're scanning glue track, for example, where the glue is transparent and you can't get the top surface of your glue accurately with the current spot detection methods. So This is just an illustration here showing a typical example, a typical application where you've applied glue around the edge of a part, and you're looking for anything like breaks in the glue, or you're looking for overflow, underflow, anything like that where the glue is not conforming to the requirements. So the challenge with the traditional spot detection method is that it will work fine on the surrounding area of the metal. So anything opaque, of course, works fine. But then when you get into the glue bead itself, that glue, because it is translucent, will actually let the light of the laser through, and it ends up basically glowing from the view of the camera. So you get this very wide spot, and you can't reliably detect the top surface, which is what you really want to see. So instead, you might get points in the middle. And of course, this is not desirable because you want to get a proper measurement from the top of the surface, and you want to get that profile from the top of the surface. So this new method is basically looking at the spots for every column and looking for the top instead. So the results look more like this, where it does the usual detection for the surrounding area, but then on the glue bead itself, it finds points closer to the top and allows you to get a much more accurate measurement from the top, measurement out of the sensor. So this is something that's supported on all 2400 and 2500 sensors. It's exposed in the advanced sensor panel. So you just have to select translucent under the spot selection mode, and then away you go. You've got your more accurate detection of those top points. This is again quite CPU intensive. So you would use this together with GoMax or GoAccelerator on a PC, because it does require more CPU power than the regular spot detection method, and so to perform at like several kilohertz performance, you would want to be accelerated for this. Okay, so that wraps it up for all the features that I was going to introduce. I think I haven't seen any more questions here, Aaron, but if there's anything that you can think of for questions, or just we can open it up for questions right now. If you have a question that you haven't asked yet, you can go ahead and type that in the comments.
Yeah, absolutely. Well, we're opening up for comment or for questions. So in the one from Jerome, do you know when firmware 6.1 will be available to download?
Right. So the beta release is planned to come out before the end of this month. If not end of this month, it would be very early next month that you'll see the beta release up on our website. And it will also be, we'll be sending out email notifications, of course, when that gets released. And then the final release will be out before the end of the year. So that will be after the beta period. But of course, we encourage everybody to try out the beta and give us feedback. Let us know which features you're particularly interested in, and ones that need any sort of refinement. That's always great to hear from everybody during that beta period.
Excellent. And I'm actually, if I could, I'm just going to hijack the screen and do a quick reminder that, so everything that Nathan was demonstrating today, so the emulator, we don't have the 6.1 available quite yet, but if you do want to try out our emulator and play around with some of the tools, then you can just go to our website, LMI3D.com, and just right here, if you don't have an account already, you'll have to make one. But you can download all of this and try it out for yourself. The surface measurement tools, profile measurement tools, and really get hands-on. If you don't happen to have a sensor right now, you can try it out. Right. Well, I don't really see any other questions, so I think we'll wrap it up for today. If you do have any questions, for those of us who are joining right now, please do I'll just put this back up here. If you have any questions later on today, anything percolates, just reach out to us at training@lmi3d.com. That's the email there. And we'll be happy to connect you with someone that would be able to answer your question. And again, just keep an eye out on your email box. The recording should be available in a couple of hours. And with that, I think we will wrap it up. Nathan, thank you so much for joining us. Robert as well, thank you so much. And all of you at home, thank you so much for joining.
Yep. Thanks a lot for tuning in.
All right, take care. Bye.
Okay, bye.